Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already, please subscribe to the channel and leave a like for this lesson. Now, in today's lesson, I'm just doing a quick one. We are going to prove these identities, and hopefully you'll be able to work them out by yourself. Let's go into the lesson. All right, so the first one that we have is this right here. So sine theta plus cos theta is equals to 1 minus 2 cos squared theta over sine theta minus cos theta. So what we'll do here is we're going to take this side of the equation, which is the left-hand side. So we have sine theta plus cos theta. And basically what we'll do here is we're going to introduce this term on the denominator, but when we introduce it on the denominator, we have to introduce it on the numerator as well. So that will be times sine theta minus cos theta all over sine theta minus cos theta. So this is done so that we don't lose the meaning of the question. So this and this can cancel out to give us 1. So now this will be equal to multiplying. We multiply this times this, and this is over 1. So we say this times that. So this is a difference of 2 squares. So let me just put it here. When you have a plus b multiplied by a minus b, this is basically equal to a squared plus minus b squared, minus b squared. So that is a difference of 2 squares. So now in this case, we are going to have this times this. This is a, this is b, this is a, this is b. So we're going to have sine squared theta minus cos squared theta on the numerator, and on the denominator we're going to have sine theta minus cos theta. Then we know that sine squared theta is equal to 1 minus cos squared theta. So right here we can replace with that. So we'll say this is equal to 1 minus cos squared theta, 1 minus cos squared theta, cos squared theta, all over sine theta minus cos theta. So these will add up. So basically going to be 1 negative and negative. So that will be negative 2 cos squared theta, then all over sine theta minus cos theta, which is equal to the right hand side. We have shown the first we have proved the first trigonometric identity. Now we go to the next question. All right, so for the next question, we have 1 plus sine theta over sec theta equals to sine squared theta 1 cos theta. So what we'll do here is we'll start with the right hand side. So right hand side with the opposite side. So it's this side is sine squared theta over theta. And what we'll do here is we're going to multiply by the additive inverse of this. So we say times 1, it will be plus there, cos theta. We do the same with the numerator, 1 plus cos theta. So this is done so that we don't change the meaning of the question. Okay, so as you can see, this is a difference of 2 squared on the denominator, but on the numerator, when we multiply that out, we're going to have sine squared times that. So this would be equals to sine squared theta plus sine squared theta cos theta all over. So this is the difference of two squares. It will be 1 squared minus cos squared theta. Okay, so that is that. Then or the other way that we could do it, let me just the other way that we could do it, I think this one will even be much faster. Let's just cancel that. Cancel that. The other way that we could do it is we can try to cancel the denominator here. So let me change my strategy. So what I'll try to do is cancel the denominator. I think this way it will be more faster. So, and by doing that, I'll just say this is equals to 1 minus cos theta over 1 minus cos theta. Or what I can do is this. Just say, I can say this. Okay, so from the start we have our left hand side. We have our left hand side, which is sine squared theta over 1 minus cos theta. What we can do is that we know that sine squared theta is equals to 1 minus cos squared theta, and this will be equal to 1 minus cos squared theta all over 1 minus cos theta. Then what we'll do here is we'll use a difference of two squares. So we know that if we have a squared minus b squared, this is equals to a plus b times a minus b. So this will be equal to 1 minus cos theta times 1 plus cos theta all over 1 minus cos theta. Okay, so like that. Then this and that will cancel and will remain with 1 plus cos theta. And basically what we'll do here is we'll multiply by sec theta on both sides so that we try to produce this. So we say sec theta over sec theta. Then when we multiply that out, we're going to have, so on top we have this. So we're going to have this times this, that will be sec theta plus sec theta plus sec theta cos theta, then all over sec theta, all over sec theta. And now we can simplify this. So we know that sec theta is 1 over cos theta. So this will be equals to sec theta plus 1 over cos theta times cos theta all over sec theta. Then this and this will simplify and will remain with 1. So this will basically be equal to sec theta plus, okay, so this will be equal to sec theta plus 1 over sec theta, right, which is equal to the left hand side that we are. Okay, left hand side. Okay, so for this one we had this identity 1 plus sine theta over sec theta equals to sine squared theta over 1 minus cos theta. So what we did is we started with the left hand side. So we say this is sine squared theta over 1 minus cos squared theta. Then we expanded this as 1 minus cos squared theta, knowing that 1 minus cos squared theta is a difference of two squares, so it can be written as 1 minus cos theta times 1 plus cos theta, and all over what we have in the denominator here, and we simplify. Then here we introduced sec theta, because we have sec theta here. Then we multiplied throughout, and it has simplified simply to that. So that other procedure would have taken longer to complete, but this one has taken shorter. All right, so we go to the next one, which is this one right here. All right, so for this one, we're going to reconstruct the equation a bit. So we're going to start with the left-hand side. Okay, so on top we have tan theta plus sec theta minus 1. And at the bottom, we can group this and this because we have an idea of 1 plus tan squared theta being equal to sec squared theta. So we want the tan and the 1 to be together. So we are going to have 1 plus tan theta minus sec theta. Okay, and what we'll do here is we're going to introduce the additive inverse of this. So this will be as one group. Then what we're going to say is this is multiplied by 1 plus tan theta, then plus sec theta, then on top the same thing, 1 plus tan theta, and plus sec theta. Then we multiply them out. So this is a difference of two squares. Remember, this is our A, this is our B, and that is our B. So this will be equal to, on the denominator, we're going to have what? 1 plus tan theta squared minus sec squared theta. And on the numerator, if you check properly, we have this, which is tan theta sec theta, and we also have it here. So this is tan theta sec theta. Okay, and this is -1, and that is +1. So if we were to write the +1 on the other side here, you would see it more clearly. So if we were to rewrite the +1 here, we say +1, then we erase this. This +1 comes this side. You'll see that this is this, and we have a minus there, and a minus, and this will be a difference of two squares, which can be written as tan theta plus sec theta squared minus 1 squared. So that is a difference of 2 squared. 1 squared is basically just 1, so we can just write that as 1. Then we start expanding. So here we'll expand this. So this will be equal to tan squared theta plus sec squared theta, then plus 2 tan theta sec theta, then minus the one that we have here, then all over, we expand this as well, that is 1 plus tan squared theta plus 2 tan squared theta, then minus sec squared theta. Okay, now here we know that tan squared theta plus 1 is equals to sec squared theta. So now if we were to transpose the 1 here, would have tan squared theta equals to sec squared theta minus 1. So we're doing so because we have a negative 1 here, and we have a sec squared theta here. And here we know that this will be x squared theta, so it will cancel with this part. So let me just write out what we're going to have. So we're going to have this being equal to, so this will be tan squared theta, then this and this are being grouped to give us this. So we have this will give us this, so it will be plus tan squared theta. So we group these two. Then we have plus 2 tan theta sec theta. Okay, so hope you've understood that. So this sine squared theta and the negative 1, when grouped, they give us tan squared theta, which is this one. Then at the denominator, this when grouped, it gives us sec squared theta. So we're going to have sec squared theta plus 2 tan squared theta minus sec squared theta. Okay, so here we see that these will add up, so it will give us 2 tan squared theta plus 2 tan theta sec theta all over. So this and that cancels out, so we are going to have 2 tan squared theta. Then what we're going to have here is we can factor out 2 and tan, so we can factor out 2 and tan, so we can factor out 2 tan theta. Then what will remain with here is tan theta. Then here we're going to remain with sec theta all over. Here we're going to have the 2 and the tan theta, then we times times tan theta. So basically we multiply this, we get tan squared theta, and this will give us back to that. So we see that this and that cancels out, and what will remain with is tan theta plus sec theta all over tan theta. So here we know that tan theta is equals to sine theta over cos theta. So this would be sine theta over cos theta plus 1 over, this is cos theta, then on the, we do the same on the denominator, that is sine theta over cos theta. So what we'll do is we'll multiply by cos theta both on top and at the bottom. Okay, so so here we're going to have cos theta times this, so the cos and the cos will cancel out, will remain with sine theta plus cos theta times that will remain with 1 because the cos and the cos will cancel, and here we're just going to remain with sine theta, which is equals to the right hand side. Okay, so that is equal to the right hand side, which is what we're looking for here. All right, so this question might have had an error, so we'll correct that error. It's supposed to be, oh, it's cos, yeah, cos, supposed to be sine, theta, not cos theta at the bottom. So this question has, so it's supposed to be sine theta. Supposed to be theta. Sine theta. Okay, which is the result that we have produced here. So have been error. Okay. All right. So is it. So it's supposed to be sine theta here, and right here it's also supposed to be sine theta, not cos theta. And that proves our identity. And see you in the next lesson.